data structures using C, evaluating the postfix expression using a stack. So in this lecture, you will learn the algorithm to evaluate a postfix expression using a stack. If you remember, we have already done using a stack, we have converted infix notation into postfix notation, and there we use the stack. Now we go a step further. We have a postfix expression with operands and operators, and we have to evaluate that and get the result of that. So that is what we are going to do during this session, and to do that we are going to write respective subprograms, function subprograms in C, and implement the algorithm for converting postfix expression using a stack. So here we have the algorithm. That is, as long, now we have in our postfix array, that is character array, the whole postfix expression, which contains only operators and operands, that's all, and spaces. So what we have to do? So as long as we have not come to the end of that postfix expression, what do you do? So you may get either operator or operand number. So if it is a number that is operand, push it onto the stack. I've got one example here. So this is the postfix expression. So first I get 10, I would push it onto the stack. Next I get 5, I push it onto the stack. Then else if it is an operator, here for example third one is operator plus, what do I do? If it is an operator, I pop operands, these two numbers, I do this operation, so 10 plus 5 is equal to 15, and then I push that result onto the stack. So I go on doing it till I come to the end of this expression. So when it comes to the end of the expression, it comes out of the loop and the stack will contain the final results. I pop that result and print that result. So this is the algorithm to evaluate a postfix expression. So let us take some examples. So here you have got infix expression 10 plus 5 divided by 15 minus 10. So postfix of that is 10, 5 plus 15, 10 minus, let us see how we get, this is the postfix expression, and we are going to use that postfix expression to evaluate using stack. So what do we do? 10 is a number, I push it onto the stack. 5 is an operand, I push it onto the stack. Then next is operator, I pop these two numbers and do the operation plus, it becomes 10 plus 5, 15, I push it onto the stack. Then I get one more 15, I push it onto the stack. I get one more 10, I push it onto the stack. Then I come across the next operator minus. So 15 minus 10 is 5, I push it onto the stack. Then I get the divided symbol operator. So 15 divided by 5 is 3. Then I have come to the end of my postfix expression. There is nothing more. So I pop this number and print this result. So 3 is the result of this mathematical calculation using stack, using postfix expression. So dear friends, you have got two infix expressions here. I would like you to first convert this infix expression to postfix expression, then show how using a stack you can evaluate these two. So pause this video for some time and do it conscientiously, and then we will proceed. Let me take the first one. So this is the infix expression 10 plus 5 power 2 divided by 10 minus 15. Now to do that, there is a very easy way is there to get to the postfix expression. What do we do? We convert this infix notation into a binary tree. So for example 10 plus 5, all the operators are going to be root of this tree. So 10 plus 5 power 2 divided by 10 minus 15. So this becomes the binary tree, and if you do the post order traversal, you get the postfix expression. So post order traversal is left to right root. So 10 5 plus, then 2 power, then 15 10 minus divided by. So as you see, this is the postfix expression. Very easy way to convert an infix expression into postfix expression. So it will help you later because once, for example, you are asked to convert infix notation into postfix expression using stack, you will do that using stack, then you check whether it is correct by using this binary search tree. So now we have the postfix expression, so 10, 5 plus etc. What do we do? So first number is 10, therefore push it onto the stack. Next number is 5, push it onto the stack. Then I get operator. You pop these two numbers, add them and push the number onto the stack. Then you get 2, push it onto the stack. Then you get next operator. That means there's a power, 15 raised to the power 2. So do that and push it onto the stack. Then you get 15, push it onto the stack. 10, push it onto the stack. Minus, therefore pop these two numbers. 15 minus 10 is 5, push it onto the stack. Divided by push it onto the stack 45. You have come to the end of the postfix expression. 45 is the result and print that result. So next infix expression is here. 5 plus 2 into 5 minus 10 by 2. So 5 plus 2 into 5 minus 10 divided by 2. So this is the binary tree. We need to do the post order traversal, that is 5, then the right tree, 2 into 5 plus 10 divided by 2 minus. So as you see, this is the postfix expression of this infix mathematical notation. Now you use this postfix expression with the stack and evaluate the value of this postfix expression. So 5 goes onto the stack, 2 goes onto the stack, then 5 goes onto the stack into, therefore pop these two numbers, then 2 into 5 is equal to 10, push it onto the stack, plus, therefore pop these two numbers, 5 and 10, 15, push it onto the stack, then you get one more number, push it onto the stack, 2, push it onto the stack, divided by operator. Therefore 10 divided by 2 is 5, push it onto the stack, minus 10, the minus, that means minus 15 minus 5 is equal to 10, you push it onto the stack. You have come to the end of the postfix expression, therefore pop this number. This is the result of this infix expression which was converted into postfix expression and evaluated using a stack. Now let us get into the C program. So these are some of the constants we have declared already earlier. So you know, operator 1, operand 2, right parenthesis, left parenthesis. We are not going to use this, but we need them later when we convert infix notation to postfix notation and evaluate them. So here is the stack which contains operand, and top of course indicates the number of operands which are been loaded onto the stack, and we have created, this is a new type, stack is the new type, and we have created a variable called S. This is infix notation, infix character array. This is postfix character array. So this is, and these are the 4 functions which are related to the stack, which you are familiar with: pop, push, stack empty and init stack. And these are the 3 functions which we are going to use to convert postfix expression in or evaluate the postfix expression. So to do that, I am going to write, I will be writing this function subprogram, EvalPostfix. So it will take that postfix expression and using the stack it will evaluate and return the value float. Therefore float is the return value of this postfix expression. To do that, I am going to use this function which we have written earlier, scan expression. If you remember, this is going to this time it is going to scan only the postfix expression. So if it is an operand, it is going to return 2. If it is an operator, it is going to return 1. So that will help us to find out what is the type of token which is generated. If it is one operator, this operator variable will contain plus, minus, plus, into, etc. If it is 2 operand, then this operand will contain some number. Then this is one more function, process. So you pass the operator plus, minus, etc. It will pop 2 numbers and do the operation using that particular operator. We will go through that. So here is the main program. Very simple, just a few lines. This is a float result. This is the title of the program. So input postfix expression. So gets postfix. So postfix, whatever you enter goes into the postfix array, and init stack, you initialize the stack. Then you just call this function EvalPostfix. It is going to take that postfix expression, use that algorithm and calculate the result, and it returns the result and you print that result, get ch. So this is the just main program, only this much, nothing else to you to do. Everything else is done by functions. So we are coming to the whole program now. All these are constants. Here we have got that stack. Here you got infix, postfix. Infix is not necessary at the moment. So we are going, these are the 4 functions. Then you have got one more 4 functions. I have written one more function, get postfix expression. You are going to use that. So we could have said gets postfix. Instead of that, I have written a function to input the postfix expression. So in the main program, as you see, get postfix expression, init stack. You call this eval expression here. It will return the result and print the result. Now let us go through individual functions. This is the function to push that operand number onto the stack. This is the function which pops that number from the stack, one at a time. That init stack, it initializes top to 0 and get post expression. It will get this postfix expression. So that is now we come to that scan expression, which is going to scan the postfix character array starting from the beginning till it reaches the end. So as I say, while ch, that is every time it is going to take each character from this postfix expression till it gets. So first we ask, it may be an operator or operand. Operand means it's a number. So if it is digit, if it is a digit, then you have to convert, because that is ch is a character. So number in character. So I have to minus 0, then it will give you the integer number. So ch minus 0, then operand will contain a number, and you say return operand. Or see, if ch is an operator, one of these symbols, then you copy that symbol onto operator and you say it returns operator. These two are not used here, they are used earlier, but we need them later. So at the end it is going to return no more, it is going to return -1. So this function is going to scan the postfix expression and return the value, either it will be 1 or 2 if it is a operator or operand, and these two variables will contain the respective values. We have made it pointers, because unless you make a pointer, the value will not come out of this function. So with that we come to the very important function algorithm we have gone through, eval expression. So we have got operator, operand, type and result. So we are scanning as long as it is not come to the end of this postfix expression. What do we do? So if this type, if it is operand 2, you push that operand onto the stack. If it is operator, you call that function where it will pop 2 numbers. It is going to do the operation and return that value, and you get at the end you pushes that value onto the stack. So here you use this ultimately you pop that number from the stack and put it on the result and return the result. Here you have got that process. So if it is operator, if it is plus, then you add those 2 numbers, you have popped those 2 numbers, add those numbers, minus, deduct the second one from the first one, multiplication. When you come to division, you have to be careful. Check whether number 2 is 0. If it is not 0, only you do that division. Otherwise, you say divide by 0 error and push that result onto the stack. So that is what we are going to do. And with that, there is an example here. So this is the postfix expression. So I start scanning that. First number is 8, second number is 7. So onto the stack. Then you have added those and pushed it onto the stack. Then you come to 2. So you push it onto the stack. Then 2 power. When it comes to power, it finds 15 raised to the power 2, so it becomes 225 onto the stack. Then you have got 7, then 2, then minus is there, minus, therefore you deduct 2 from 7, you get 5. So both of them are on the stack. So 225, on top of that there is 5. So you have come to the end now. This divide. Therefore, what do? Divide 225 by 5. It is 45. It is pushed onto the stack. Then you, in the main program, you pop it out, and then this is the result. Or in that function, you pop that value. This is the result which is printed. So thank you.